Here's a number 6 type question. A farmer grows pumpkins, X, and squash, Y. The number of kilograms of squash is more than 0. 2 times the number of kilograms of squash is not fewer than 108, less than 9 times the total number of pumpkins. The number of kilograms of pumpkins is more than 14/23 of the total number of kilograms of pumpkins and squash. The selling price of a kilogram of pumpkins is $7.79 and a kilogram of squash is $6.40. The farmer wishes to maximize their sales. Graph the polygon of constraints and find the number of kilograms of pumpkins and kilograms of squash that will maximize sales. The number of kilograms of squash, that's Y, is more than 0. So we have Y is greater than 0, like that. 2 times the number of kilograms of squash, that's 2Y, is not fewer than, that means greater than or equal to, 108 less than what? 9 times the number of kilograms of pumpkins, so 9x. 9x, then you have to put the 108 less than after it. 108 less than what? 9 times the number of kilograms. It's going to be 9x minus 108. 2y is not fewer than, means greater than or equal to. It's not fewer than, could it be equal to? Sure. Could it be greater than? Yes. 2y is greater than or equal to 9x minus 108. I want to get the y alone so we can graph this. So I'm going to divide both sides by 2. And so the y is greater than or equal to 9 over 2x minus 54. And this is our equation. We're going to keep that. The number of kilograms of pumpkins, which is x, is more than, greater than, 14/23 of the total number of kilograms of pumpkins and kilograms of squash. X is more than, is greater than, 14/23 of the total. Total is x plus y. 14/23 times open bracket, x plus y, close bracket. Cross multiply that 23, or multiply both sides by 23. And when I do, we get 23x is greater than 14 times x plus y. Then the 14 is going to come in, multiply the x, and multiply the y, distributive law. So the 14 is distributed to the x and the y, and we end up getting 23x is greater than 14x plus 14y. I want to get all my x's on one side, so I'm going to subtract 14x from both sides, and 23 take away 14 is 9x. 9x is greater than 14y. I'm just going to switch the sides. The crocagator's eating the x's, still eating the x's on this, written this way. And then I want to get the y all alone, so I'm going to divide both sides by 14, so y is less than 9/14 x, and that's our equation. That's it. We only have the 3 equations. That's our first equation. This is our second one. Our third one is here. Let's graph those 3 equations back into our program. Y is greater than 0. Y is greater than 0. Here's the line y is equal to 0. Greater than, I'm going to make it dotted. Dotted, greater than, I'm shading above. Y is greater than or equal to, so solid line, 9 over 2x minus 54. There's 2 things we could do. We could figure out an x value that's going to get us close to 0. 9 times 6 is 54. And if x was equal to 12, 12 divided by 2 is 6. There you go. So when x is 12, we get 0. We could do it that way, or we could actually go to our b value of negative 54. Let's do the first way, and we'll do both just to show you. When x was equal to 12, y is equal to 0. The slope is 9 over 2. Delta y is 9, the delta x is 2. 1, 2, and then up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And notice it actually will go through the negative 54. Let's go and have a look. If we scroll way down here, there it is, negative 54. But we could have started at negative 54 and moved over to and up 9. This is greater than or equal to, so shading above and solid line. Shading above and solid line. Shading above, solid line. The last equation, or last inequality. Y is less than 9/14 x. The b value is 0. There is no b value, so it's going through the origin. And the slope is 9/14. It is less than, so dotted line and shading below. 9/14. Going through the origin, 14, I'm going to go over 14 and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Dotted, and we are shading below. Let's double check that. I'm going to make the polygon by going over here, and I'm just going to click on the 3 vertices that make up our polygon of constraints, and there we go. So this is the polygon of constraints. The next thing, I want to figure out the optimal value. We want to maximize sales. We're probably looking at something close to the A, but the A is not part of the feasible region, so it can't be a solution. So we're probably looking at this point right here, which is 13.8. We can plug in a whole bunch of values and see which ones work. We could also use our scanning line to go into a spreadsheet. A lot easier to work with a spreadsheet. Here is a spreadsheet. Our equation is 779 times x 7.79 times the x value plus 640 times the y value, like that. The x is 13 and the y is 8. So 13, 8. That gives us $152.47. If the x was 13 and 7, so we have 13 and the y is 7, we end up getting, let's fill that in, $146.07. That's less if the x was 12 and we had 7, even less, so we're going in the wrong direction. We've found our maximum. 14 and 9, we can't use it because it's on a dotted line. That dotted line is not included in the solution. So that means this point is not included in the solution, even though it's on this solid line. It has to be both solid lines. That point is not a viable point. 13 and 8, and it's $152.47 is the maximum value. 13 kilograms of pumpkins and 8 kilograms of squash. The cost of that is $152.47, and we press return to see if we're right. And that's it for level 6. Have a good day.